All right, guys, well, this is what you've been waiting for, the big, nasty words in math, right? Two big ones, and it says word problems. You know what? Forget the word problems. Let's think of these as life problems, okay? The most important thing that you could ever learn from math is everything to do with percents increasing and decreasing, okay? Especially when it comes down to interest rates. Look, interest rates, even though they might be small, even a 2% interest rate on a home loan, if your home loan is $300,000, 2% over 30 years is a lot of money that you're going to have to owe on top of the $300,000 loan, okay? So you need to understand the idea of exponents, exponential increasing and decreasing, especially increasing, especially when you're getting a loan for a car or something that you just might not have the cash for up front. This is probably the most important life application you could have. Now, I'm going to come up with some funny examples, some serious ones, but these are life problems, okay? These are the things you're going to face every day. All right, so let's, well, maybe not every day you're buying a house. Let's continue. This is everything you guys should already have. Just a recap of what we've been through, and it's on the last video. If you did not see the last video that had this information on it, please go back to it. I have it all in a playlist on my YouTube channel. Just make sure that you go back through, and they're all labeled as video 1, 2, 3, 4. So just find this video, find the playlist that it's in, and you should be good. Make sure you have this down, though. It's really important with these percentages. All right, so here's our first word problem. I'm going to read it aloud with you. It says, you have a Spider-Man comic book number 1. I mean the comic book that the first time Spider-Man ever showed up in it, right? You paid $500 for it. Oof. If the comic value increases 5% a year, how much will it be worth in 10 years? I want you to think about that for a second. If our value is increasing, we should definitely be worth more than $500, right? This is what we're investing in. You don't go buy this comic book just to read it. You're buying it because you're investing in something you know is going to increase in value. The question is, how much is it going to be worth in, let's see here, 10 years, right? So there's a few things here. And I want us to back up all the way to what was just on the last slide. F of x equals a sub 0 times r to the power of x. And the reason why I know I can use this, why I know it's going to be a ratio, is because there is a percent increase in here. Okay? And that's what we just got done talking about. Percent increases will always be a ratio. Okay? If it increased by $5 a year, that's just adding 5 each year, right? This is not a $5 increase a year. This is a 5%. So whatever was worth last year, right, it's going to be 5% more this year. And then the 5% more the next year. So it's actually going to slowly increase, but eventually it's going to rapidly increase. You'll get to see that as this plays out. So a couple things I need here. I need my initial amount. This actually is pretty easy to identify from this problem. How much is the comic book worth right now? Because I just bought it. Hopefully it's worth $500. So I have my initial amount, which is $500. That's given right here. If the comic book value increases by 5%, well, the ratio, it's given as a percent, so we do have to convert this to a decimal, but we also have to do some other magic on it, right? It's worth 100% as it is right now, right? 100%, which is $500, so it's worth 100%. But then it's going to increase by 5% every year, right? So that's a total of 105%. We don't write ratios as percent, we write them as decimals. So we just move that decimal over twice, and we're left with 1.05 is my ratio. So I'm going to circle that down here. I'll leave the work here. So two of the things that we need right here. I can actually write the function for this now. So f of x equals the initial amount, which is $500. We'll run out of room here. Move this down just a bit. Times r, and the ratio here we said is 1.05. I'm going to go ahead and put that in parentheses. 1.05, and then to the power of x. Okay, that's just the function that represents the comic book's value over time, where x is the number of times that it's going to increase. And it does say that it's going to increase 5% a year. So x is going to represent how many years pass by. And so now I can just plug in a value for x and say, how much is it worth in 3 years, 4 years, 5 years? In this case, I want to know how much is it worth in 10 years. Well, in 10 years, this comic book value will increase 10 times. Because it increases once a year. So on year 1 it increases, year 2 it increases, 3 increases, 4 increases, up to 10 years. So in that time it will increase 10 times. So we need to find f of 10 to figure out how much this comic book is going to be worth. And that's just going to be 500 times 1.05 to the power of 10. Yep, I'm totally using my calculator. I don't know about you, but calculator is definitely going to be your help here. And you can use Google's calculator too. Just write onto Google or whatever. Just use a search engine, find calculator. So let's see here, 1.05 to the power of, this is where I told you guys I'm doing to the power of is the caret right here. To the power of 10, right? And then we hit enter. And it says 814.4473134. Do you write the whole decimal? Remember the context of what we're talking about, right? My calculator just gave me that f of 10 is 814.44733134. What are we talking about? We're talking about money. We're talking about comic book value. Money doesn't go out this far for us, right? So I'm going to round this. When I convert it down to what I'm talking about, my context is money, I'm going to round up to the nearest hundredth spot, right? So just to remind you guys, this 7 tells that 4 to round up to a 5, so we're just going to say 45 cents. However, for the sake of my class, I'm not testing on round now, I'm testing on this. So she said 44 cents. Okay, I see what you mean. I don't think we're going to care about a cent off or two. So, all right, so that's what we're talking about here. That's a word problem. Try this one out. Yep, I totally made up a country. Uzbekistan. That population is 195,000, and it's decreasing by 12% a year. Okay, so this population is dwindling down, and then it's asking if the decrease stays constant, 12% decrease a year. What is the expected population in 12 years? Okay, so every year it goes down 12%, and it's going to do that for 12 years, and I just want to know what the population will be like in 12 years. Okay, so we're still going to use, I see it this time a percent decrease, so I know that I can use a sub 0 times r to the power of x because it is exponential. Every time you see a percent increase or decrease or interest rate, it will be exponential. Okay, what's the initial amount? Well, that's 195,000. Okay, that's what the population is at right now before it starts decreasing. Let's see here, 12% decrease because it's given as a decimal. We're starting off with 100% of the population. It's decreasing, so we are going to subtract 12%. And this will happen every year. So that's going to give us 100 minus 12% is 88%, but written as a decimal. Let's move that decimal over twice. It's 0.88. So there's my ratio. To write the function for this, and I believe in your assignment you'll be required to do this, is just, it has f of x there for you already. You will need to substitute in the 195,000 for your initial amount, right here. And then you'll need to write in your common ratio. Your common ratio is 0.88. You can put that into parentheses or do times. I'll do parentheses because I think that looks better. 0.88. And then to the power of x. And again, the way that you do the power of x on your computers and for your assignment is to do this caret sign, which is shift 6. Right? And then to the power of, I'm sorry, I just wrote numbers there. Move this stuff over here. Excuse me. That's to the power of x. Right? So we haven't plugged in a number yet. We haven't substituted a number for x yet. So this is the function that represents this. And now I need to know what the population will be like in 12 years. Right? What's the population after 12 years? That's just simply replacing x with 12. Now, I want you to keep this in mind. Sometimes populations decrease every month. If the decrease is every month, then that's actually decreasing 12 times a year, right? This is decreasing 12 times a year, but it's also only decreasing once a year, right? A whole total of 12% a year. So, one time a year for 12 years is 12 times. So that's going to equal 195,000. Times 0.88, it's our rate of decrease, and then to the power of 12. You could also just put that in the exponent, and then pull out your handy calculator and type away 195,000. We're going to go speed mode here. Go. 0.88. Forgot an 8 there. To the power of 12. And we get 42,055.8. Let me just write that whole thing down so we can talk about it. Woo! So at 12 years, we will have 42,000 equals 55.87539. But Ken, this is the biggest question. Can you have 0.87539 of a person? Now, we could joke around and say, well, yeah, but no. Let's just be serious about this for a second. You can't have 0.8759, so on and so forth, of a person. So we had to talk about people. You can either be a person or there's not a person. Okay, that's all there is to it. There is no such thing as half a person. So f of 12. I'm going to round up because I see this 8 and this tells me that I need to round that 5 up to a 6. So 42,056. In 12 years, the population will probably be about 42,056 people in my made-up country. Okay? So remember rounding. Rounding always plays with context. When we're talking about people, just round to the nearest whole number. When we're talking about money, that's 2 decimal places, the nearest hundredths. And just whatever the context may be, that's usually the most played out context. So, all right. That's all the word problems I have for this video. I am going to make another video, though. It covers a little bit harder problems. And they're kind of more essential because generally we have, look, so far we've talked about decreasing a year, okay? Increasing a year. That's actually not the case. Interest rates usually hit monthly. So if I want to know how much money my debt is going to incur just based off of interest rates per month, then I need to look at how many times that's happening a year. So anyway, that'll be our next video. We'll talk about some additional exponential word problems and that. As for right now, you can go down to the videos below and try those out. Okay, good luck.